last presentation was me talking a little more about the operations side of this. It's less about the detailed how does all this work in operations, more about what all the different words mean that will actually probably be talked about in much more detail over the next 3 days. So do I have control? Sorry.
No, Emma, just please say next slide when you're ready.
Okay, cool, thanks. So there's 3 different pieces in here. Some of it Kevin has actually covered already, so I can step through pretty quickly. But the overview here is talking about what things like distribution, supervisory control, and data acquisition actually means, smart meters and advanced metering infrastructure, and various other pieces where we start to get into all the different types of MS or management systems that are involved in this. So starting off initially with just a few definitions here, we had EMS, which is Energy Management System, OMS, Outage Management Systems, and DMS, which are Distribution Management Systems. And by the end of this presentation, I will be absolutely sick of saying MS, but we'll get through it. So briefly covering...
Emma, excuse me, Emma, is it possible to put yourself on webcam?
Sure, I'm in an odd space, but I'll try, hold on. I don't know if that worked, but that was the best I could do at the moment. Sorry, my computer isn't giving access to different things just now, so that's me giving it a shot. So briefly covering here where the management of distribution and transmission actually is and where it's going. Later on today, and I'll try and get my webcam working for then if you like, is where I'm actually going to cover in detail what the different sensing and measurement devices actually are at the distribution level. This is more about where the data comes from in that regard. But here we're talking about where transmission and distribution SCADA is working. So next slide. So starting off initially, the SCADA platform also is generally, I think Kevin already introduced, at the heart of electric utility operations. It's where we primarily get real-time telemetry for different systems that support utility control sensors. It's much more prevalent in transmission. You'll hear a lot more about high voltage SCADA type systems than you do about low voltage. But as we develop more applications for management of the system, as Kevin was talking about voltage management, distribution SCADA is becoming pretty important. But as we move on a little bit, and I'll talk about that again later, so I'm trying to skip through a couple of things at the moment. But an outage management system is a tool that essentially utilities deploy to manage their grids and restore power during outages. It's evolved essentially from what was initially, and if you could go back a slide, sorry. What was initially a trouble ticket program to essentially this sophisticated computer system where you can visualize what's going on in the system. So prior to the introduction of computerized systems in history, calls would generally be received by the utility and may have actually been written up by hand or entered into a computer and printed out for someone to go deal with it. The tickets could be manually sorted essentially and given to the customer and responded to by the outage management team and then placed somewhere for further actions. Analyzers would look at the tickets and then determine where the outage was and then go and sort it out. It worked well back then. It doesn't necessarily work well anymore with all the different types of applications, with distributed resources in the mix, and also we just have better technology now to manage things. The early versions of when we moved into computer-based OMS were essentially used to improve outage prediction accuracy, to find the locations better and actually restore the system better. Initially, they were using a feeder tree, which is generally a static description of how they thought the system was connected down from the substation node out to the feeder, the transformers, and out to the customer nodes. It was the connectivity-based system used a database to represent those electrical parts or electrical relationships of the distribution system, and then essentially produced a table where it would tell you where the outage location was and where somebody needed to go fix it. Moving on from that to where we are now, there's essentially a new breed which you'll hear a lot more about later on, of outage management systems, which evolved over the past 10 years or so. I think Kevin's probably worked on some of them as well. But the systems are generally characterized by a GUI or a graphical user interface, which means that an operator can see one or more things happening at the same time, or even just look at the entire distribution system when they're visualizing, say, a very large outage that's affecting many customers. There's a few different origins for where the data comes from on that. There is distribution planning models but both of them are based generally in the geographical information system, where they essentially import a version of the topology and geography of the distribution system. So when they're sending someone out to fix an outage or investigate a problem, they know where they're going and they know the topology of it and they know what it looks like. It also helps them basically locate these things a lot quicker. And there is more connection now to measured data systems, including distribution SCADA also. So next slide. The next sort of stage that people talk about is the distribution management system functionality, which is not necessarily the outage management system, which is generally where you're looking for the trouble parts of the system. DMS is where you're actually trying to manage the system in its operational state where it's working well. It's how we put in new different types of applications. It can improve the outage management system in that it can implement various tools that will probably reduce the number of outages that you have and help locate things faster. But it's not the outage management system. So pulling them together, there's different functions here. So outage management is where people track and restore what's going on with the outages in the system, whereas DMS helps to optimize the operations over time. So we can analyze things like the state of the system, all the VoltVira applications that you heard about already, how the load is flowing. So if you're looking for overloads that could be managed by new applications or by something like demand response, then that can be managed under the distribution system, management system. And then FLISR is a fault location tool also that I'll mention a little bit later. So different systems, but yeah, you hear them interchangeably quite frequently by accident because not everyone necessarily knows entirely which application is meant to go where, and also it changes over time. So in some different utilities, they might actually be using a DMS and an OMS or various functions of it together, and they're all for management of the system, but there's various different ways it's used interchangeably. So next slide. So another evolution of all this, and I know there is probably a whole presentation on this, is the ADMS system, which is the Advanced Distribution Management System, which does actually try and bring together features of outage management, optimization, and distribution operation together. So there are about many utilities and distribution organizations are evaluating the tools they've been using here and trying to integrate those three key systems together, including the SCADA and sensing and measurement system, the advanced metering infrastructure, which is where your smart meters come in together, and the DMS into one system called the ADMS. It's an integrated solution essentially to eliminate some of the sort of redundant processes, as I just mentioned, help maintaining a singular network model so that people don't have different sets of information in different offices. It also improves efficiencies in how people communicate and manage different parts of the system. If we integrate SCADA and different measurement systems to this, it also helps get to those more advanced applications for things like voltage management and some of the new distributed resource management systems that you might be hearing about as well. It's integrated, like I said, they're trying to integrate in various ways with the AMI type networks, substation automation, but this isn't just generally the sort of normal state for most distribution utilities at the moment. It's a good direction that things are going, but there's obviously various technology roadblocks that they're working through at the moment for how computation and cost and things like that as well. So next, sorry. So some of the different applications that you might hear about in there include like a lot of the automation work. Imagine when you're developing systems that can essentially manage themselves. They have different controls for voltage management, but those operators still need to see what's going on in the system, and this is the sort of place that sits. Also being able to predict the states of the network based on things like unbalanced power flow and presence of lots of different distributed resource systems in place, different load profiles, and also how do you integrate forecasts for the systems, not just for load, but how do you integrate forecasts for things like the distributed resources operation over the day, which will now impact how your distribution system is managed and how the voltage responds also. So just the entire goal with ADMS is essentially to improve operations by integrating a lot of disparate pieces together. But obviously that's a large task to pull together, and there's various, like I said, various roadblocks for getting it done, but there's a lot of work in that area at the moment. Next slide. We can actually skip through most of this at the moment because I think Kevin already covered a degree of it, but I had a slightly different set of slides if you want to read through them later. Obviously, I think they're all available. Essentially here I was talking about the different voltage management approaches and how that matches into where the ADMS, OMS, and DMS systems are operating. But skipping through these just now, I think we're okay with what's already been said. But I did give a couple examples here of what the different voltage profiles along a distribution feeder might look like based on different types of operation. So referring back to that standard that Kevin mentioned for what the service voltage ranges are, normally, as he said, from the source, that voltage will decrease over the length of the feeder from where the customers are. But if you look to the next slide, you see how the distribution management system for voltage might be operating, where they have, say, line regulators in place, which will help bump the voltage in the middle of the line. Or there might be a capacitor sitting at the end of the line to boost the voltage over there as well. So just showing what a voltage profile actually looks like to give a little bit of a visualization of what you're seeing throughout the 3 days as well. So next set of slides. Sorry. Okay. So the last piece I'd put in here, and I'll go through this fairly quickly as well, because I think we want a few minutes at the end for questions. I'm switching roles a little bit again. I'd mentioned advanced metering infrastructure applications and smart metering. I do have another section in the cyber and communication section where I talk a little bit more detail about what different types of sensors are. But I think when the realms of operations, we wanted to talk about where smart meters and data analytics fits into that grand vision of how the distribution system will be operated in the future. So smart meters are essentially rolling out across a lot of networks. I think there's about 100 million was the last number I'd heard, and Joe can absolutely correct me if that's not true. They allow a large amount of sort of fine-grained electricity consumption data to be collected and analyzed for how the system is operating, but also for giving people, the customers, a view of what they are doing on a daily basis and how the small changes they might be making to their own energy efficiency for various reasons, how those actually impact their billing and daily profiles is one of the big uses of smart meters for customer interaction. But why is a smart meter different from other meters? On the next slide, smart meters, I have a joke at the moment, and I can't see people's faces, so I'm not sure if anyone will laugh. But in my office just now, I have a collection of different meters over time, and I was asked to remove a bunch of communicating equipment from my office. One of the meters that was sitting there had a rotating dial on it and absolutely no way to talk to anyone. And I was asked to remove it because they thought it might be a smart meter. But it was not connected to anything, so that was a little special. So that's one of the actual sort of key features of smart meters, is that they can provide communications, and essentially bidirectional communications and control. They can be linked to other types of components and back to the utility for giving improved notifications. But one of the key functions is essentially improved communications and automated communications in there, along with sort of higher fidelity data, more accurate billing, being able to actually monitor. In some of the more advanced types of them, there's ways to monitor power quality, for example, being able to use resources a little better in that there is remote disconnect functions and reconnection. Improving reliability, and some of those applications are in the other slides, so being able to see where outages are in advance using the measurement system, and also for, so as I mentioned, this more accurate billing, along with load forecasting. If you know what's been happening in the past over a period of time at set temperatures and times of the year, then you can use that data to better forecast what's happening in future also. So there's a lot of different applications as these are rolling out, and I think there's large fields of research going into new ones every year. So there's as the different technologies also improve, meaning that the things like onboard computation come into play, then there's a whole host of things that can be done there as well. So stepping on. So I think I'd taken some of these slides from Joe and his smart grid program work here, where there was a number of projects where the meters were used to the best of their abilities to actually perform these advanced functions. So things like being able to look at service disconnections or reconnections after an outage, where there was a high degree of operations and maintenance savings because we can actually reduce truck rolls by doing that, meaning the utility doesn't need to send out a person to physically do an action because the meter was able to do it from being connected to the outage management system and the DMS and the distribution management system. So there's a various metrics that are used here to do with truck rolls, to do with cost per truck roll. But I think this example here from one of the co-ops was used to show that they'd avoided 6,000 truck rolls by deploying smart meters everywhere. There's also various other applications they can find, which might include meter tampering, meaning somebody trying to bypass the meters so that they can get free power, essentially. Being able to detect outage, like I said, being able to see the clusters and where the outage is, and also improve the management of voltages along the system. The first part of managing your voltage is knowing what your voltage is. So being able to manage that is a key function. We can move forward fairly quickly on the next few slides. One of the ones I do like, the Florida Power and Light example. One of the things, and I was working in the last week and managed to damage a transformer, and this was actually pretty interesting. But the transformers with minor coil damage were something that they were particularly worried about in this area, but they weren't sure how to find distribution transformers. As you saw from Kevin's presentation, there's not just one on a distribution line that they're looking for. There may be however many hundred sitting there, that it's pretty hard to monitor every single distribution transformer, even if sensors cost $1 each. There's issues with how all that data would even flow into one place. So in this experiment, or in this pilot, they were essentially looking to how to proactively manage the transformer program in distribution operations by using the smart meter data, and how do they monitor those voltages and determine if there's a particular problem. So this was a particularly successful application where issues were identified with a particular make and model of transformer that was out there, because there was consistently high voltages being read at those locations. With some fancy analytics being put on top of that, you can perform some pretty advanced features. So next slide. So this was one of the way this came out. Also, the visualization here is a pretty solid example of this as well, of how do you see where the voltages are, what are you looking at, and how do you interpret that. But as I mentioned, the analytics are pretty important. You need to be able to understand what you're looking at as well. And so in this example, that we're just looking at the voltages over time and working out where those faults might actually be. So next slide. Another, you can move on another one, sorry. And another one. Another interesting feature, I think I mentioned visualization a few times, is being able to actually allow a field crew to be able to actually see what's going on, not just with a piece of paper that's given to them where they go to a location, but being able to visualize the system themselves with a heads-up display. So more frequently now, you'll start to see your operations crew standing out there with iPads rather than with a notepad. And they may be looking at where the outage is, what the piece of equipment is, any sort of augmented reality type information they might have of what that piece of equipment, what the history of it was it replaced, is that the piece they're looking for. So there's, by improving the availability of the data into the OMS and DMS systems, they can then put that into the hands of the operators to be able to use the AMI system to a much higher degree. And the users can also then customize that to essentially see what they want to see and what they're used to seeing, for them to be able to look and work out what's going on. I think there's a lot of applications of this in the future, where putting smarter devices as well into the hands of field crew is a very useful activity. So next. So I think I'm getting towards the end of this, but one of the interesting applications which combines a lot of different things together has been FLISR, which is fault location, isolation, and service restoration. All those pieces kind of coming together into being able to restore the circuit automatically, and so get power back to the customers, or even just avoid a longer term outage. Basically, and if you look at the distribution system with these sets of houses fed from a couple of different substations, imagine there's a fault in between a couple of different houses, but they're currently all fed from one end versus the other. if they can use the AMI and other sensing technologies to be able to determine where that fault is, automated switching and self-healing systems can help you to then open the tie downstream, close the other tie, backfeed to the houses. And then probably the only people that are actually impacted by it are the ones absolutely closest to it, rather than what you might be used to seeing when a whole distribution feeder is out for a number of hours because they're trying to restore the feeder from the substation as was, rather than reorganizing around the different switching patterns they have. So it's an interesting application where it brings together, like I said, AMI, OMS, and all the various systems as well. So last slide, I think. We can skip past that, it's a video. But. So I actually put a lot of the further reading that was requested in line in the slides. Obviously, I'm referring to a lot of different contacts here and different websites for people to look at, and I put them in line with the slides because sometimes it's easier for me to find things directly when I'm looking at the slide that I wanted more information on. So